Hello, everybody. Welcome to today's webinar. Let me just move that onto the right screen. I'm Erin. I'm the Business Development Manager here at Softree, and I get to be your webinar host. With me is Matthew Dickey. He's going to be doing all the heavy lifting in today's presentation, which is going to be an introductory workflow for the design as well as the earthwork optimization of a pipeline using RoadEng with our Optimal technology. So a little bit of housekeeping before we get started. First of all, this, as I just mentioned, it's about a workflow, not about the specifics of engineering a pipeline. So our specialty really is about developing software and easy to use software tools. We are not pipeline engineering experts. So focus on the workflow part, the little tiny details, we'll leave that to you guys, the experts. The next piece of housekeeping, you are all muted, but we definitely encourage you to ask us questions throughout the webinar. You can expand that little GoToWebinar panel section. There's a spot there you can type in questions. You are anonymous when you ask them, and we'll make sure we keep it that way when we chat through the answers. Finally, if you are watching this off of YouTube in the future, because that's where all of our webinars do end up, please, if you've got questions, you're welcome to type them in the comment section below, and we will get to those in the future. So a little bit of background to get us started. As this is an introductory webinar, some of you may not know who we are. So first off, I'm Erin. I'm the Business Development Manager at Softree. And with me is Matt. He is our training manager. And our company, Softree, is a civil engineering software developer based out of beautiful but very rainy, especially today, Vancouver, Canada. We've been around about 30 years or so, got our roots in forestry. And yes, that pun was definitely intended. Our core product, RoadEng, was created to support the design of forest road networks in really complex terrain. And with that, it was really focused on the engineering side of things, not the CAD side of things. So RoadEng, the product we're going to be talking about today and using to do the workflow, is a really fast, easy to learn software that doesn't require a drafting background to become really proficient in it rather quickly. And because of that, again, as I mentioned, we're focused on the engineering side of things, not CAD. It's great for quick planning, analysis, visualization, costing, and it's capable of creating finished detailed designs too. Optimal, it's an add-on within RoadEng. It's all about earthwork optimization. So here it looks to basically adjust your vertical alignments profile to minimize embankment excavation and all those associated movement costs. Finally, I feel like I should mention this because it's the elephant in the room. Despite its name, yes, RoadEng, it is used for a variety of other projects, including being widely used within pipeline energy projects. So I guess we could change the name of it to Linear Infrastructure Eng, but that really doesn't quite have the same ring to it. A little bit more of an intro in terms of the pipeline side of things. So RoadEng has been used, as far as I know from my conversations with some folks, thousands of kilometers of pipeline have been designed in RoadEng. One of the key things that makes RoadEng actually quite good for pipelines is the fact that you can design really long alignments in the software. You know, it's not uncommon to have 50-kilometer plus alignments inside of RoadEng working on modest business grade laptops, as well as those being based on really large LiDAR data sets. So as Matt's going to show you in some of the workflow side of things, you can bring in lots of data, you can make long alignments. The one kind of, I'm going to say shortcoming that we just want to talk about as well as the workaround for it. So common practice on the road side of things, which is obviously where we were founded, we use vertical curves that are based on parabolic curves, or assigned with, I should say, parabolic curves. Obviously in the pipeline industry, circular curves are the thing. So the workaround here is it's a close approximation. So we can use a multiple of 100. So for a K value of 1, it's approximately equal to a radius of 100 meters. So something that I'm sure Matt will touch on a little bit more as we get going. The other thing I did want to mention, again, that optimization side of things that we are going to include in our workflow today. It also is, it's not just about reducing the cost, it also can help you get, grades to be exactly what you need them to be, and then balancing that design. So the plan for today's webinar. Our software is modular. We're going to start in the terrain module. Here we're going to bring in that topo data. So for example, we can bring in LiDAR, it works with other topo surfaces as well, build our digital terrain model, get our contours, add some background imagery for context, save that, and then we're going to head over to our location modules. This is our alignment design module. Here we're going to set up a cross section for a pipeline. This one actually is going to include our pipe as well as some workspace. We'll create our horizontal alignments, create a vertical alignment, talk a little bit about costing and optimization and what that can do for you, output options, and then in a second project, we're going to get a little bit more sophisticated. We're going to talk about ground types, creating subsurface layers, pits, and then in a little bit more detail about earthwork movement. So that is our plan on a page. If you have questions as we go through this, as I mentioned, type them into your comment section. We'll tackle them at the end. And now, enough for me. Matt, can I make you the presenter?
All right. Yeah. And I am going to look at another monitor here, so I am going to turn off my
I'm
camera.
also going to turn my camera off too, so you guys can focus on the design. But yeah, enjoy the webinar. If you have questions, please do type them in.
Thanks for the intro, Aaron, and we'll jump right into things. And yeah, so one thing you'll notice when you open the software is that when you install RoadEng, you get 2 modules. So we're going to start out in the terrain module, which is this guy here. We're going to build our tin, so our triangular regular network to represent our ground. And then we're going to jump over to location, and we're actually going to design our alignment. And I think Aaron mentioned it in the introduction. We're focused on the workflow. I'm not a pipeline expert, so I familiar with a little bit of it, but if I refer to our alignment as a road, just bear with me, and I might make some other silly terminology mistakes. So we're going to pop open terrain, and I'm going to click insert file, and I'm going to insert my LiDAR data. So in this case, I just have a 1 meter DEM, so it's in a TIFF, but we support a bunch of different file formats, and if we had the LiDAR data in LAS, LAZ, we could bring that in. If we had it in XYZ or CSV data, we could bring that in as well. So lots of flexibility for data import options. I'm going to bring this in. I'll hit OK. Default settings are going to be appropriate. I'll come back and talk about what the selection option is at the end. So this is a useful feature for those of you that are dealing with really long projects. So we can kind of isolate the information that we want and ignore the information that we don't want to help us extend our range for how far we can go in a single project. The TIFF carries my projection, so I'll leave that as is. And there we are. So we're bringing in a big blob of points. I'll click off to the side, so those points have the display property turned off in them, but I can see I've got 8.5 million points to model. So to take that and turn it into a surface, I'll come up here, click Terrain Modeling, I'll click Generate. I could just model the surface if I'd like, and I can turn off contours. Or I can model contours at the same time. I can set the intervals to be whatever I'd like as well for that. The surface itself is modeled very quickly. Contours will take a little bit extra time. So in the sake of not watching my computer think for a couple minutes, I'm just going to jump ahead, and that's what it would spit out if I hit OK here. So we've got our terrain surface. We're looking at it in the plan view. If we'd like to look at it in the 3D view, just kind of see what we're up against, we can open the 3D view and cruise around, and we can see we've got some pretty humpy bumpy terrain in this example. So we have what we need. We could hit File, Save. Optionally, we can bring in ortho imagery or other line work, and we can use that for added context of where things are at in our project. So I hit save there, so just it's thinking. Once that's done thinking, I'm going to just bring in an ortho image. And or I can show it in this file just while that saves. So I've got that data that we've brought in previously, and I can click Home, Import, Live Maps, and I can isolate the information that I'd like. So if I want my ortho imagery from that location, I can. I can cancel there. Oops. I could also change my map provider if I'd like. Once I've decided what I'd like, I can hit Save. I can turn up the zoom factor to increase the resolution, and this is going to be downloaded onto my computer. So I've already downloaded this in a decent resolution, so just to show the workflow, I'll leave my zoom factor quite low so it downloads quickly. So I've got that, and let's save that. Oops. In here, and I'll just, so it's taking it from Google Earth. It's going to be in lat long, and it's going to do the transformation for me into the current coordinate system that we're using. So there we are. And this one's done saving. So we could have done it in this just as easily. After the fact, we can go in here and we can add in that file that we've downloaded as well. So there we are. So we've got our surface created. We've checked it out in 3D, and for the sake of having a better idea of what's going on, we've also brought in an ortho. I'm going to switch gears and jump into location. And we're going to focus more on the design side of things. So here I'll click File, New File. I'll set my terrain surface to be that topo. I'll hit OK. I'll just start with a single point in the center of my terrain. And I'll use my default cross-section template to start. So we've got our plan view, we've got our cross-section, our profile, which is just showing a dot because we don't have a line yet to work with. And we've got our 3D view. I'm going to start out by just doing a couple, kind of make it pretty items, optional items as well. But I'll come in here, and as I design my road, I want it to be modeled in my 3D view. So I'm going to set that. I'll just use the final merge surface. And I did it. I called it a road. I meant my alignment, my pipeline alignment. So we'll hit OK. And so that's being modeled, and then my topo surface, I don't want to just see the contours. So I'm going to turn off my contours, and I am going to model the triangles, and I'm going to set my alpha channel just so if I'm in cut, I can see through that surface. So the alpha channel controls the surface transparency. It's going to take a moment to render. In the plan view, I'll click plan options, and I'm going to add in that background that we've downloaded. So I've got my image bound background. There is a draw order here, so I'll just shift that up. And there we are. And now I can start getting into the design side of things. Now, before I start setting up my alignment and figuring out where I'd like to put the road or pipeline, I want to make sure my cross-section geometry is representative of what I'd like to build. So in this case, we aren't building a gravel road. So for that, our cross-section geometry is stored in a template, and we can assign our different cross-sections in our assign by range function. Let's just pop this template library open. And I can see I have 3 different road examples, and then I have 2 different pipeline geometries that I've previously built. So these templates themselves are mostly holders of information. So there's a few parameters that we can set in the template, but if we expand these, we can look at the individual components that we're working with. So I've got that. If I come in here and I want to make, and this is a road template, so if I wanted to make that road width 10 meters wide on one side, I could. And I could do the same on the other side, or I could delete that, copy, paste as right, and away we go. Now, if I had something that I wanted to build that was substantially different than a road, I could go into my E-library. I can select all of these different component folders, and we could piece together something from scratch using these individual components. So I could come in here and I've got a trench that we could start with, and I could build my trench and then add a work site off of that, etc. Add my pipe in, and away we go. Or maybe I wanted to use something like our penstock template and just adjust my dimensions around there. Remove a surface, and I could build that out to be what I'd like. So in this case, I've already taken my different components and put them together. So we've got a few different components here, and I've got my trench depth set. I've got my pipe dimensions set, and I've got my work area set. So I've got a 23 meter wide work area on one side, and I've got a 4.5 meter work area on the other side. So that's what I'll go with. I've got one for the work area on the other side, and I could very easily take this, hit copy, paste as new. I'll call it work area on both. I'll give it a identifier so it's easy to make sense of what's what. And I could just change that dimension, or I can click that, click copy, paste as left, away we go. So I'll hit OK. So I still just have my roadway being assigned. I'll go to assign by range and actually choose the, let's go with the work area on the left. Now I'm going to assign this for the entire alignment, so from station dot dot to dot dot. I don't need to know the station that it's going to begin and end. But if I wanted to switch back and forth between different templates, I could assign those by station range. So I'll hit OK, and now we see that updates. So next I'm going to start figuring out my actual alignment. So I'm going to right click here, add an IP tool. I'm going to come up to the northern extensive, our surface. I'll set that there. And I'm going to start clicking in an alignment. I should hit zoom to extend so we can see what's happening here. So I'm going to climb up the hill. See that goes up. Oh. I'm going to get that to render, and we'll be able to see that it's interacting with the ground. And we'll continue along here. So I'm not going to worry about all the details yet. I can see I'm going through a dip. Maybe I add a horizontal IP in there. And I'm going to continue along here. And I'll just start by exploring this one example. Ride the ridge. Start dropping down. And we'll end there. And I can see him going through a big hump there, so I'm just going to move my alignment over. Now, we're probably going to also want curves rather than these abrupt changes of angle. So I can go through and I can say, well, at that IP, I want to add a circular curve. So, and for our horizontal curves, we are using circular curves. It's just the vertical that we have K values applied. And I can say, well, at this location, I want to use a radius of 300. I'll hit apply. And that curve is applied. And I can cycle through and I can make those changes as I'd wish. So I've got my default set at 100 meters, which is what I'd like in this case. If I wanted to reset that default to something else, I could click that button. But I want to use that default, and rather than going through and clicking in the vertical curve for each one of those, I'm going to just assign it here. So it'll save a little bit of clicking. So we've got those. And we aren't stuck with what we've assigned. So if I wanted to look at that high point and see, so we've got those. And we aren't stuck with what we've assigned. So if I wanted to look at that high point and see what I have going on here, well, maybe there's an opportunity to wiggle around a little bit. So I'll move that IP back here, push that in here, making it worse here. So we can quickly make adjustments. So I've got something roughed in so far in my plan. We'll go with that. Vertical behaves very similarly. So I can right click in here, add edit IP, and I can begin setting this up. Now I'm not going to take this too far just because I'm going to use a faster method and use our optimizer here momentarily. And so I can go through, I can click in that alignment, I can assign my vertical curves just as I assign my horizontal curves, only I'll use my vertical curves panel instead. If I want to fall in line with that 100 meter radius, I'm going to approximate that with a K value of 1. And there we go. So next comes, well, we could actually, and I will really quickly rough this in. If I was designing this entirely by hand, I'd pay closer attention to make sure that my pipe isn't floating in space there. So I'll drop that down here. And I'd want to maybe wiggle around to follow the ground as best I can to reduce those earthworks. And we can see as we make our adjustments, we have our mass haul diagram down here, which is tracking our surplus cuts and fills. And again, I'm just going to rough this in really coarsely just for concept for now before I jump into the optimizer. So we've got that set up. Now in order to optimize, we need to generate costs. So our costs are being driven by our earthworks. So up here I've got my ground types. So I've got overburden material. Right now, and we'll make it more complicated here in a bit, we just have one subsurface material assigned, which is our default. So that default is overburden, and we have a cost assigned to it of $4 a cubic meter to excavate it, $2 a cubic meter to place that material, and then we have our material movement costs in here. So free haul over end haul, we have hauling and loading costs for those. So based off of that, we can click recalculate, recost, and it's going to spit out a total cost in our Project Explorer panel here. So the cost for my earthworks as designed is $5 million. Now just a little caveat, that is just including my earthworks, and I am not including my pipe. If I want to include my pipe costs, it's not a big deal. I can come in here and I can say, well, that material is being tracked as surface volume 4, and I could go in and say, well, surface volume 4 is a certain material, and I could equate that back to whatever I expect to pay for my pipe. And my guess for what a pipe costs probably wouldn't be very accurate, so I'm just going to leave that out and we'll focus on the earthworks. So we've got a quick cost estimate for what we're dealing with, and we can use that to compare different options. We could improve that design probably considerably. Actually, I know it can be considerably just given how quickly I clicked that in. But even if we did a really good job of adhering to all our design parameters and minimizing our cuts and fills, we aren't going to do as good of a job as the optimizer. So let's set this up to optimize our alignment. I'll come in here. I'm going to say, well, let's allow the software to move that vertical alignment up and down and find the minimum earthworks cost. So for that, it's going to have to sample along the alignment. I'm going to tell it to sample in 20-meter intervals. I can tell it, well, in this case, I've got a vertical alignment that we can follow. So it could be plus or minus 10 meters of this line. If I hadn't clicked in my alignment yet, I could do it based off of the ground line. I'll come over to the standards, and here I can put in things like minimum and maximum grade. So of course it's pipeline. We just need machine access to actually install the pipe. So we can go really steep. So I'll set it at a minimum maximum percent of 30. I'll set my minimum K values as being 1 for both sags and crests. I'll click Add Edit. And up here I can add a minimum curve length if I'd like. So if I want to avoid a bunch of little curves, I can put in, well, let's have a minimum curve length of 60 meters. The other thing we could do, in this case, we're going to have curves butted right up against each other. If we wanted to smooth that out, if we were physically bending the pipes versus just relying on the deflection when placing them, we can go into variable curves and tangents, and we could say, well, I want a minimum tangent length between those curves as well. So a minimum distance between curves. We'll just go with curves fast. We'll go control points. So control points let us say the alignment has to be at this elevation at this station. I'm going to leave it unconstrained. We'll talk about pits later. We've already touched on unit costs, but I'll talk about that in a little more detail here after. And then we have constraints. So just to start, the only constraint I'm really going to focus on is minimum cut. So in this case, if I want the bottom of my pipe founded on in situ material, I'm going to say, well, I've got center line at the center of the pipe. I want to allow that center line to be up to my radius above ground. So in this case, it's 0.6. So let's just go in here. So I'll say minimum cut minus 0.6 since it's minimum cut. And we've applied that. And then I can click vertical optimization. And for the sake of timeliness, I'm not going to let this run. I'll jump to one that's done. But we could hit vertical optimization process. And the first thing it's going to do is it's going to go through and it's going to sample along our alignment. So in this case, we've got 7 or 8 kilometers of alignment, sampling 20-meter intervals. It's going to count up to from 0 to this number, and then it's going to actually, so that's just the sampling. The solving is going to be very quick in this case where we're using fast curves, and it's going to generate a new alignment. So I'll hit cancel just so we don't have to wait. And we'll jump over to this one. Resaved that terrain file that's referenced. It's re-looking at all the referenced alignments. So that's why it's referenced files. So it's just reading things in again where I've made changes to those. So it is dynamically linked to those terrain files. So I'll let that recost. But we can see right here we've got an alignment that undulates to match the ground very closely, and it maintains those constraints like that minimum cut, our maximum gradient, and the K value of 1. So that would take, longest part for that is the actual sampling to run the optimization, and then it spits out this new vertical alignment, and we've gone from being a total cost for our earthworks of $5 million down to 1.3. Of course, nothing else is the fact that it's quicker, but don't expect to cut your project costs by a fifth. It's if you actually do a good job designing that, it'd probably be closer to 20% savings. But yeah, we can see we've generated alignment using the optimizer. And with this, we've got our fast curves. So we've got curves butted right up against each other. I've run the same optimization using, actually I won't, the variable curves with tangents, and we can see we don't have our curves butted right up against each other, so we've got a smoother alignment that way using the other option, but it costs more. It costs 1.6 million instead of 1.3. Now that's kind of a quick overview of our project. If I want to go with this one, we could say, great, let's produce a drawing package for it. And we could jump over and create what we So usually, if we hadn't have already set up our document, it would be, well, we've got this blank document that has a chapter, a book, and pages. So we can say, let's add in our various subviews and build this document from scratch if we'd like. Or it could be that, well, I want to use something that's already set up. So I'll go on to our Access Web Library and I can pull in a series of chapters to begin building my document using those predefined chapters as a starting point. So I'll do that here. So there I've got my plan over profile. I can change logos, move things around, customize it as I wish. I could add another chapter with my cross-section information, build out a title page, notes pages, etc. But once I do that once, I can save that entire document and I can bring that in the future. So in this case, I'll open a book layout. And so I've got a series of chapters in here. So I've got my plan over profile. Well, I've got both alignments showing up here. So I'm going to turn that off to just show my current. And we've got our cross-section geometry, summary tables for earthworks. So we've very quickly kind of gone through the process from start to finish to design and optimize an alignment. Now with that being said, I'm going to back up and add some useful features to add and account for complexity and add more information and help with the analysis of your projects. So actually, I'm going to jump over to this one here. So we've got that alignment that we've clicked in from scratch going up here. if I wanted to explore other options, I can just click Add Horizontal Alignment, and say I wanted to do something entirely from scratch, as we did when we started out here. We could click New. If I just wanted to see, well, what makes sense to make maybe a minor adjustment in this, what is the better option, I can say, well, let's make a duplicate from horizontal alignment 1. That gives me a carbon copy, and I can say, well, is it going to make more sense to come up this side of that ridge? So I can pull that around here, and I can re-optimize that, and I can say, well, that's going to be my better option. Let's further pursue that. So being able to create multiple alignments in the same file is super useful, and helps add confidence that you're actually following the cheapest route. Now, back here, I'm going to just delete that. The other thing is, we can take into account a whole bunch more complexity than just using a default ground type and costs. So with that, we could come in here and we can say, well, let's add some subsurface information. So we can say, well, got that ground type file for library where we've got different materials that we can pull from. So each one of these different materials has geotechnical parameters associated with them and cost parameters associated with them. So if I'm going through hardpan, excavating my hardpan material, it's obviously going to be cheaper than excavating solid rock. So we can account for that. And usually if you're excavating solid rock, you can cut that steeper than if you're excavating hardpan or overburden material. So we can assign different subsurface information along different sections of our road. We can account for expansion compaction factors if we wish. And if there's something that's missing in this list, we can click New and add in our new ground type to represent whatever we'd like. So I'm going to say we have hardpan over fractured rock. And to start, I'm going to just say that we have a depth of rock of 2 meters. Now I can say that's for the entire alignment if I'd like, or it could be that, well, say at station 2000 to 2700, we've got solid rock, so not rippable rock. Sign this here first. So I'll say that we still have that hardpan material, but it's shallower. We can go solid rock. And so let's make that. And it's thinking here, recalculating all the different materials that we're dealing with. So there's our different horizons, and up here we can see where we're going through that solid rock. We've got a different depth. And because my cut slope angle is set to auto, it's pulling in the cut slope for that specific material. So we can account for that. Another thing that we can do is if we had our own subsurface information, we could apply that. So let's go up here and we can say, well, let's add our own train for subsurface information. So beforehand, I've created a bedrock terrain file. And this is optional. So just if you have good subsurface information and you want the surface to reflect that, you absolutely can. So I've added that subsurface file. Actually, I'm not going to cheat. I won't make it recalculate the whole thing. So now when I go into assign by range, I can come in here and I can say, well, use surface information for that rather than a fixed offset. So we can do that there. I'll do that for all of these. That's my depth to rock surface. And away we go. And another thing we could do would be, well, if I wanted to assign specific fill types for certain materials, I can. So instead of just using whatever material is available, I could say, well, from station 3200 to 3,500. I want to place fractured rock. So I want to use a select material rather than any old material. Site prep, if I wanted to worry about stripping my organic layer, I can come in here and I can say, well, let's strip our organic soils layer. I'll make that based off my slope stakes. Away we go. I can add a clearing width as well. So I could say I want 100 meters either side of my prism, and then go an additional 5 meters if I have any long cuts or fills. So outside of the slope stakes, and we can account for that. And away we go. And again, just for the sake of not watching that think, I'm going to leave that be. So now we've added different material requirements in our alignment, and we can keep adding more complexity to it. We've changed our costs. The alignment's probably going to change. The optimal solution's probably going to change now that we've added that additional information. I got that. I'm going to switch over in here, and I'm going to talk about pits and constraints. So we need our pipe to be founded on good material. So we're probably going to end up with a surplus of material. So with that, I may want to add spoil sites. So if I wanted to add a spoil site at station 500, I could go into my pits, and I can leave it as a smart pit, and it's going to figure out how much material it makes sense to haul to that location to dispose of it. And we can add numerous pits along the length of our road, and it'll solve for the best ones to use. We can add a site prep cost if it costs money to open those up, in which case it'll look at, well, is it cheaper to not open this up and haul it a little bit further? And if we had a situation where we expected to have a deficit, we could add boros. We can also add a bunch of material movement constraints and flexibility in here too. So in this case, if I was dozing this project and I didn't want to doze up steep hills, I could say, well, my material movement is only allowed to be dozed uphill if that's less than, say, 8%. So I could say max grade 8%. Say we can ignore short sections, and there. So from station 70 to 145, it has to be moved backwards, whereas once we go over that hump, from station 1890 to 1970, it can go forwards. So we can help plan some of the construction side of things. If, going back to our pits, if we expected to have a surplus of material and we wanted to allow that material to just be disappeared adjacent to a road without, or adjacent to our alignment without actually having to haul it away, we could add side casts. And we could assign that by range if we'd like, or we can say, well, I want to allow side cast anywhere that slopes are less than 25%. Oops. Oh, and I can dispose of up to a certain volume per linear distance. So I'll say up to 15 cubic meters per linear meter can be disposed of adjacent to our alignment. So we've got that. So we've added in all this information tabularly, and we could go through and recost this alignment that we have, and it's going to change our costs, but we could also go through and we could re-optimize it, and it's going to find the new optimal solution. So I've done that here, and again, just to save not watching that go through and calculate. And we have our new alignment. We've got our mass haul as before, but down here we've got our opti-haul. So this opti-haul is actually planning for where individual materials are coming from and going to, rather than what the mass haul is doing, is just grouping those all together. So this is what the optimizer is using when it's doing its costing, and it gives us a really clear picture of where we plan to do those earthworks and move them to. So I can see I've got side casting going on here. I've got one material going ahead at this location and another material going backwards at that location. I'm using a spoil site. So all really detailed stuff. that you can ignore if you don't want to consider it, but if you do want that flexibility to account for the nitty-gritty stuff, you absolutely can. And if we want that tabularly, I'm just going to copy this to clipboard. We can see we've got a bunch of different summaries for different things, including pit summaries, how much material is going to our pit. We've got material movement summaries by material type. So that's my hard pan, and that's my fractured rock. So pretty flexible. And of course, you can show that information in data tables as well. So with that, kind of dove into the nitty-gritty stuff there at the end, but that is kind of the complex side of optimization. The last thing that I'm going to show is just with pipelines, it's not uncommon to have projects that are hundreds of kilometers long. So just going back to when we first brought that information in, we've got a couple strategies that can help. So one would be if you didn't know where you wanted to put your alignment, there's no preliminary alignment at that stage of the project, we could come in here and right off the bat, we could, and assuming that we had a much larger area, we could do our selection. So we could thin that data down on import. So I could bring in, skip every 9 points and bring in the 10th. So that would be kind of globally thinning down our data. We could save that topo surface, do our preliminary design, and once we roughed in where we'd like, we could switch over to a higher res surface and really narrow in as we get it to that issued for construction level package. So that would be just thinning everything all at once. The other thing we can do is thinning based off of a feature. I'm going to bring in a shapefile here to start. So if I had a preliminary alignment and I was fairly confident that I wanted to be within, say, 150 meters of this preliminary alignment, I could bring in my DEM data. I'll go to selection. I'm going to add a corridor. So I've got that. I'm going to tell it my corridor width. So total width, 300 meters, 150 either side. So I've got that, and I don't want to skip any of my information here. So I'll keep that high resolution, but outside of that corridor, I'll skip all of the points. The import takes a little bit longer, just as it figures out what it wants to bring in, but we get a ribbon of data representing our corridor. And well, just for the sake of timeliness, I won't do my contours again. So now I've got this narrow band of data. I'll save that as topo narrow. So we could refer to that when we're starting out our project, or if it was something that we started with a course file and wanted to switch it over after, maybe falling off the surface here, we'll see. I could go in here and I could switch that surface to be the narrow one. And it's going to recalculate, and wasn't really focused on staying within that footprint, but if I am on that footprint, we won't see fills running away, and if we are, we could add, or off of it, we could add in additional data where we need it. So with that, yeah, I'm off the surface there. That makes
This might be a perfect segue, Matt, into actually one of our questions, which is, if you're ready for that, to transition into question mode, it is, how do you extend the survey width to accommodate a template? So in this case, if you don't have sufficient width to your survey data, how do you fix that?
okay. So there's a bunch of different solutions you could do there. Of course, the perfect world solution is, well, you get the survey data and you just insert that into your terrain file and you remodel the tin. In which case, lickety split, everything updates and you have your information where you'd like it. If that is not an option, or if you're looking for an interim solution until you can get that data, you could always add in your own points and line work to fudge that surface into the terrain file if you'd like. But let's just see here. So I'm going to move this over. So for this to work, you do have to have your center line on it, but in this case, I have my fill slope is actually extending off where I have survey information. So if I'm in here, I can tell it, well, to extend that survey surface an additional 50 meters based off of a sample 10 meters in. So it's saying that's the slope and it's extending that out. And that little tick mark here is showing me where my real surface ends and my interpreted surface begins. So in this case, if I turn off extend ground, we can see I'm falling off the surface here now. So a couple different solutions. Of course, the best one is if you can get the survey data added into your terrain file. If you can't, we can interpolate that. We can interpolate it automatically in location if it's just that your fill slope or cut slope is extending outside of the surface, or you can add that in terrain.
Awesome. Let's tackle a few more. I know we kind of ran a little bit long with our introduction to RoadEng, which, by the way, Matt, I'm impressed. You only called your project a road twice in the webinar.
Well, I did it once and caught myself, so it was a little...
Yeah,
yeah,
not too bad.
I can do that a bit more still.
The next question is about cross-section templates. So it looks like it's two parts. The first one is, can you share today's template with us? And the next one is, or are there services to assist us in developing our own cross-section template?
Yep. So yes to both. We'll look at who sent that and we can follow up with you outside of this, but we can share the template that I'm working with. The other thing is I kind of skimmed over that for the sake of timeliness, but it's pretty easy to work with these. So just if you're intimidated by them, encourage folks to make an attempt at it, and it's really not that bad. But if you're looking for something really complex, we can tackle that as a service. So hopefully that answers that.
Yeah. Next question, and this one I'm actually not sure the answer of. So can RoadEng windows be on separate monitors, or are you confined to the overall active monitor?
Oh, yeah. So for that, I've got two monitors here. So if I'm just sharing one, but if I pull that over to my other monitor, I can work on that other monitor fine. I'd say I wanted to move my plan view over there. I'll just pull it over there, and away I go. So yes, is the answer.
Good. I was a little bit nervous I was going to make you show a messy desktop on the other side.
No, I'll
Awesome.
hide that.
Cool. Well, we've got a bunch of questions left here, so just to let everyone know, if your question is unanswered, it's probably do maybe two more. We will get to it over email like we usually do. The next one is, can I import or export a land XML surface?
Absolutely. And of course I've got my stuff extending to where I don't want it. So yes, we can. So the land XML format is great for a bunch of things. I assume our question asker already knows that, but for anyone that's not. So it's meant to be a really universal format to share things like tin surfaces or alignments. and it's shared across different design platforms. So if you want to go back and forth with different design softwares, you can, or if you want to use that for construction staking, it's a great format for that as well. So yes, you can do that. We can bring in an alignment from a land XML. So add horizontal new, and one of the options here is to bring it in from a land XML file. And then if we had like a tin surface that we wanted to use in terrain, we can bring that in as well here. So new, of course, insert is what I meant to click there. Yeah, we could bring in a land XML file. Both terrain and location also rate that as well. So save as, and we can see we've got a bunch of options to export to different formats, land XML being one of those formats. So yes, you can in both versions or both modules.
Excellent. And we're going to do one more. I know we're over time. Last question. How can you save a template for multi-plot? I'm presuming they're wanting to share it as well.
Absolutely. So let's, despite my runaway fill there, actually, which one did I? Yeah, it's this one that I built. All right, so for this, we can come in here and we could save out the individual chapters if we'd like. So I can hit save chapter and we could save that. And if we want that to appear in our little drop down here, saving it to the default directory will get it there. But you can save that anywhere. Could be any folder on a desktop or server, etc. And yeah, you could share that with other folks using the software the same way that that you would any other file. So that's a chapter. We can do the same thing for our book layout. So if you want to use that as a company standard or something like that, where you've taken the time to build it and get everything where you'd like to, at least for a starting point, you can absolutely share that across an organization. A couple things that I'll just add in that kind of makes it worthwhile for me to mention. Of course, all this information is useful to have for construction. So if I wanted to take this document and have a georeferenced document that I can use in the field, I can save it as an Avenza file. I could plot it to a PDF, share it to a shapefile if I need to share it with the GIS department. So sharing that information is pretty straightforward. The other thing that jogged my memory on is the cross-section templates. So for this, you don't have to set this up every time. And if you notice when I open the software, these two templates I had were automatically there. So for that, we can save our cross-section templates much the same way as we can with the multi-plot. I can save it out as a new file name. If I want this to automatically appear when I open the software, I'll save it over the normal.tpl, and then whenever I open the software, I get those templates that are associated with that normal file. So that's
awesome. Well, hey, thank you everyone for joining us today for this introduction to RoadEng Civil Engineer with Softree Optimal for pipeline design. We covered an awful lot of ground, so if you need to, this video will be up on our YouTube channel in the near future, usually within the next 24 hours or so. You can go through it, pause, take note of what's happening, because Matt tends to go fast and cover an awful lot of ground, but thank you for joining us, and we hope to see you again at another upcoming webinar. You can check those out on our website, softree.com/free-webinars. And with that, enjoy the rest of your day, everybody.
Thanks, everyone.